Hello everyone, welcome to the session. In this session, we will take up number analogies questions. These questions were given in recent SSC exams 2019-20, and we are going to discuss different logics which are appeared in the recent exams. Not the same kind of logic, different kind of logics that we discussed. And even before going to the questions, once we'll discuss what exactly analogies questions and how we need to answer the analogies questions. You will be given like this: n1 is to n2 proportion n3 is to question mark. So what we have to do it is, we have to identify the logic from n1 to n2, and whatever the logic that we identify from n1 to n2, same logic has to be applied from n3 to n4. So this is exactly pattern of analogous questions. n1 to n2 we are going to check the logic, and n3 to n4 we are going to apply the same logic. Okay. In recent exams, they went a little bit extension. N3 is to N4 proportion, N5 is to question mark. Even in this way also they are giving, but the model will remain same. In this case, N1 to N2 we have to check the logic. Similarly, we have to check the logic from N3 to N4, and in both the cases we have to get the same logic, and then we can apply the same logic from N5 to get the N6. And one more important point is, while answering the analogies questions, you have to keep choices in your mind. Okay, if you are not looking at the choices, n1 to n2 relation can be defined in so many ways. Let's take an example. 2 is to 4 proportion 3 is to question mark. If it is given like this, 2 is to 4 proportion 3 is to dash. If you don't have the choices, 2 to 4, we can relate it in so many ways. Basic ways plus 2. And by applying the same logic, we will get 3 plus 2, 5. For suppose, if the 5 is not there in the choices, then definitely we have to think in another way. So like this, we have to keep on applying the logics until the answer that we get that is available in the choices. So we have to keep on applying the logics, and don't think that you are applying one logic and you got the answer. If it is not there in the choices, question is wrong. That is wrong way of thinking. You have to keep on applying the logic until you get the answer that is available in the choice. Now the same question can be represented in another way. 2 into 2 4, 3 into 2 6. So my answer may be 6 also. Even if it is not available in the choices, I may represent in another way. 2, 2 square. N is to n square logic. Applying the same logic, 3 is to 3 square, that is 9. Even 9 can also be my answer. Not only in this way, in so many ways we can represent. I will represent in another way. 2 into 3 is a 6, minus 2 is 4. Applying the same logic, 3 into 3 is 9, minus 2 is 7. Even 7 can also be my answer. So like this, we can apply in so many ways. But important point is whether these are answer choices, these answers are available in the answer choices or not, is important for us. So until you get the choice, you have to keep on applying the logics. So this is what exactly analysis stand for. I hope it is clear. So choices plays the main role. Let's discuss the questions. Now look at here. 29, select the option that is related to the third term in the same way as the second item is related to the first term. Okay, it is term. Make a small correction. Okay, 29 is to 13, proportion 37 is to dash. Okay, 29 is to 13, proportion 37 is to dash is our question. No, by looking at the given question, for first instance, I will check the difference logic, because numbers are very small numbers, so easily we can identify the difference. 29 minus 16 is 13. Apply the same logic. 37 minus 16 will be 21. Is it available in the choices? No, it is not available. So difference logic is not possible. Then I will try to think in the product way. Okay, but here to here checking the logic is not possible. Or we can check, but while you checking, you have to remember the point, what exactly? 29, 13 is less than 29. How much it is less by? In the difference logic, it is 6. If you go with the product or in the division way, 29 divided by 2 is 14.5. 29 divided by 2 is 14.5, and it is how much less by? Minus 1.5. So what I can write? Divided by 2 minus 1.5. Apply the same logic. Or in the reverse way, you may check the logic in this way also. 13 2s are 26 plus 3 is 29. You may write into 2 plus 3, or you may write divided by 2 minus 1.5. By applying the same logic, from here to here, 37 divided by 2. 37 divided by 2 is 18.5. 37 divided by 2 is 18.5. But what is my logic is divided by 2 minus 1.5. So 18.5 minus 1.5 is equal to 17. Or by going through the choices, I can say that 17 2s are 34 plus 3 is 37. So it is available in the choices, so no need to go for further logics. There can be so many ways you can represent, but in one of the way we got already the answer, no need to go further. Okay. So basically what I am going to check is difference logic, then product logic, then n square, n cube, n square plus or minus n cube plus or minus n square plus or minus k, where k is a constant, n cube plus or minus k, n square plus or minus n by 2, digit logic. All these logics we are going to check. Okay. So mostly our questions will be related to these logics, but very rarely they may give different kind of logics also. It is not that it is restricted to only this logic. There can be some other logics, but basically you may get this kind of logics. So from here to here, all will be related to squares and cubes. So try to remember the squares up to 30 and try to remember the cubes up to 15. Squares up to 30, cubes up to 15. Not only exactly the squares and cubes, try to remember the squares, nearest numbers to squares and nearest numbers to cubes. So that by looking at those numbers, you can identify the logic. Oh, yes, this is related to nearest to square logic, this is nearest to cube logic. That kind of idea you will get. So choice 3 is our answer. Now move to the next question. 19, 400, 24 is to dash. Select the option that is related to the third number in the same way the second number is related to the first number. Okay. Second number is related to the first number. So same way third number is related to the fourth number. 19 is to 400. Proportion 24 is to dash. Okay. What is the logic from here to here? I can say that 19 square is 361. But it is more than that by how much? 39. Maybe this logic. 19 square plus 39. Yes, this can be the logic. 24. 24 square is 576 plus 39. 576 plus 39. How much it is? 615. Do you have any choice like that? No. It means this logic is wrong. But I can think in another way. 19 next number is 20. Because by looking at the number 400, you should get the idea that 400 is a 20 square. So 20 square. 19 next number is 20 and the square of 20 is 400. 20 square is 400. Similarly, 24 next number is 25 and 25 whole square is 625. Is it available in the choices? Yes. So my answer is choice 4. So that's why I'm saying that recognition of the numbers are very, very important. So try to recognize the numbers from 1 to 30 squares, 1 to 15 cubes, not exactly the squares and cubes, also the numbers which are closest to squares and closest to cubes. So required answer is choice 4, square logic. N is to n plus 1 whole square. Select the option that is related to the odd number in the same way. Almost every question will be having a same direction. No need to repeat it. 12 is to 68 proportion 21 is to dash. As numbers are very closest numbers, let's first check the difference. 12 68 difference is plus 56. 56 plus 12 68. 21 applying the same logic. 21 plus 56 is equal to 77. Is there any option available with this? No. So this logic is no. So think difference is over. Now think in the product way. 12 5s are 60 plus 8 plus 8. Okay. 21 5s are 21 5s are 105. 21 5s are 105. If I do the plus 8, if I do the plus 8, I am going to get 113. Is it available in the choice? No, it is not available in the choice. But the important thing is the same 8, we can say that it is 2/3 of 12. The same 8, you can say that 2/3 of 12. So in what way I can write? Not only into 5 plus 8, that 8 can also be 12 into 2/3 of that number, which is equal to 8. Okay, now apply the same logic now. What I will get? 21 5s are plus 2/3 of 21. 2/3 of 21, which is equal to how much? 14. 2/3 of 21 is 14. 3 7s are 7 2s are 14. So finally I can say that my logic is into 5 plus 14. Not into 5 plus 8, into 5 plus 14. So 21 5s are 105. Plus 14 is 119. So it is available in the choice, third option. So you can also deal in this way. While you applying into 5 plus 8, it is not available in the choice. But this 8 can also be represented in this way. 12 is a number and 2/3 of 12 is 8. Similarly, 21 is a number. 2/3 of 21 is 14. By adding 14, we are getting 119. It is available in the choice. So I can take. So required answer is 119. Choice. Next, 17 is to 102. 17 is to 102. Proportion 23 is to dash. By looking at these two numbers, you can say that multiple of 17. 17 6 are 102. It is easy to understand. 17 6 are 102. By applying the same logic, 23 6 are 26 are 120, 3 6 are 13, 138. It is available in the choices? Yes, it is available in the choices. So choice 3 is my answer. Very simple logic. Easy one. 17 6 are 102, 23 6 are 138. Choice 3. Next, look at this number. It is a typical question. 2139 2139 is to 3246. Proportion 4262 is to dash. Now one thing you can observe here, from here to here numbers are increasing, but by applying the same logic, increasing whatever it may be the number, definitely answer should be in 5000, but none of the choices are like that. So definitely it is not the addition or not the subtraction logic. So what is the exactly logic for, even these are not closest to squares, not closest to cubes. In this large numbers, this much large numbers, they won't give squares. Okay, but it is not nearest to cubes also even. Okay, so then think in a different way. Difference is not possible, product is not possible, squares cubes is not possible, then digit logic. You can think in this way. 2 plus 1 plus 3 plus 9, 9 plus 3 12 plus 1 13 plus 2 15. Some of the digits are 15. 3 plus 2 5, 6 plus 4 10, totally 15. Some of the digits in n1 and n2 are same. So some of the digits in n3 and n4 has to be same. Let's 4 plus 2 6 plus 6 12 plus 2 14. In N3, sum of the digits is how much? 14. Now look at the choices where sum of the digits is 14. 1 plus 4 plus 6 plus 1, 12. 2 plus 4 plus 7 plus 1, 6 plus 7, 13 plus 1, 14. Perfectly matching. 2 plus 3 plus 13. 2 plus 4, 6, 8, 14 plus 3, 17. So in which option we have sum of the digits as 14? Second option. So what is the required number? 2471. Choice 2. 2471. Logic is sum of the digits. This is my approach in solving analogies questions. But those logics I am going to apply in fraction of seconds. Difference, product, squares, cubes. When you have thorough with the squares and cubes, easily you can say that these are not cubes number, these are not square numbers, even not closest to squares, not closest to cubes. That you can say quickly by looking at those numbers. Question number 6. Select the option that is related to the third number in the same way second number is related to the first number. 9 is to 86, 13 is to dash. 9 is to 86, 13 is to dash. Now here to here one logic we can say into 9 plus 5. 9 9s are 81 plus 5. Okay, difference and product together. Product and difference together. 9 9s are 81 plus 5. Now by applying the same logic 39s plus 5, what will I get? 39s are how much? 117 plus 5, 122. But is it available in the choices? No, it is not available. We have 124, not this one. But think in a different way. Can I say that it is 9 into 9 is nothing but 9 square plus 5? Instead of thinking into 9 plus 5, I am saying that it is 9 square plus 5. Now if I apply the same logic, it should be 13 square plus 5. 13 square is 169 plus 5 is 174. Is it available in the choices? Yes. So choice 3. So related to squares logic. N square plus k, where k is a constant, 5. N square plus k. 9 square plus 5, 13 square plus 5. If this is n, n square plus and that it is 5. So in this case n is equal to 13. So 13 square plus 5. 174. Choice 3. Again, 9 is to 90. 9 is to 90 proportion. 12 is to dash. 12 is to question mark. Choices are 160, 150, 156, 152. Now, can I say that it is 9 into 10? 9 tens are 90. By looking at that, I got this point. So, by applying the same logic, 12 into 10, it should be 120. Is it available? No, it is not available. Okay. The same 9 into 10, can I say that it is n and this 10 is n plus 1? Can we say that point? 9 is n, so the same 10 which I am multiplying, I am saying as n plus 1. 9 plus 1, 10. Now if I take n as a 12, so what should be this number n plus 1? N plus 1 should be equal to 13. 13, which is nothing but 12 into 13 is 156. Is it available in the choices? Yes, choice 3. Or you can also represent in another way, that is n square plus n, where n is a 9. 9 square plus 9. 81 plus 9, 90. Similarly, 12 square plus 12. 12 into 31, nothing but I can write it in the form of 12 square plus 12. 12 square 144 plus 12 is 156. So my answer is 156. Choice 3. So these are all the different logics that they are giving in exam. So you have to practice a lot to get the strike of this logic, idea of these logics. 1 is to 2 proportion 5 is to question mark. 1 is to 2 proportion 5 is to question mark. You can try it. I'll give you 30 seconds time. You can try. Look at the choices. Choices are very big. 1 is to 2, 5 is to 120 or 129 or 128 or 130. Choices are big. Big numbers. You should get some idea by looking at these numbers. The given number in N3 position is 5 and in the N4 position all are near to 120, 125. So please think in that way. If you got 130, that is correct answer. It is 1 is to 1 cube plus 1, which is nothing but n cube plus n. N is to n cube plus n. In this case, where n is a 1, so 1 cube plus 1. Now here, in this case, n is 5. N is 5. So n cube plus n will be 5 cube plus 5. 125 plus 5 is 130. So my answer is 130. If you do the product logic, 1 2 is 2, 5 2 is 10. Even if you think this number is double this number, if you take here 5 and 10, I should take 5 tens of 50. Even it is not available, but all these numbers are nearest to 125, which is of 5 cube, and even given number is 5. So you have to get the logic that way. Look at the question number 9. 12 is to 192. 12 is to 192 proportion. 15 is to dash. 15 is to dash. 12 and 192. How many times you can say? 16 times. 12 16 is 192. Yes, perfectly. 12 16 is 192. Apply the same logic. 15 16 is. If you apply the difference, it should be plus 170. Sorry, 180 plus 180. 12 plus 180, 192. By applying the same logic, 15 plus 180, it should be 195. But it is not available in the choices. So difference logic is wrong. Then I am checking the product logic. I mean, no need to do that one also even. Because by looking at that, you can say 12 16 is a 192, 15 16 is a 15 15 is a 225, or one more 15 is 240. So 15 16 is a 240, which is choice 2. Or else, can we write in the form of n square plus n? No, we cannot write. Okay. 35 is to 6. Here we have given n1 is to n2. Applying the whatever the logic is there from n1 to n2, that will be there from n3 to n4. This n3 to n4 they have given any choices. Okay. So only one pair is given, other pair we have to identify. 35 is to 6. 35 is to 6. In simple way, I can say that 35 is 6 square minus 1. 6 is the number given here. 6 square minus 1. So n is to n square minus n, I can say. N is to n square minus 1. Now, try to check the same logic in the given pairs. 9 square minus 1. 9 is to 9 square minus 1 is 81 minus 1. 80 it should be. So 80 is to 9. But it is 85 is to 9. Not the first option. Now even here this 5 square minus 1 is 24. So 24 is to 5. But here it is given 26 is to 5. So even it is not the second option. Next. Third option is 8. 8 square minus 1 should be my answer. That is 63 is to 8. But here it is given 64. So even it is not my choice. 120 is to 11. So 11 is to 11 square minus 1. 120, 11 square is 121, minus 1 is 120, 11. 120 is to 11, yes. So which option is correct? Choice 4. And the logic is n is to n square minus 1. Instead of checking the logic from n1 to n2, you should check from n2 to n1. No, three pair analogy. N1 to N2, N2 to N3 to N4, N5 to N6. Try it once. Anyone? Okay, let me explain you. It is very difficult logic. It is difficult to identify. But anyway, I will explain you. So when you see new question, please try to think in this way, because definitely here is the largest number and here is the smallest number. You can see even it is not a square, not a cube of that number. This much product they won't give you. Even it is not a proper multiple also. Okay. The given logic is difference between 6 and 4. Difference between 6 and 4 is 2. Similarly, difference between 7 and 2. Difference between 7 and 2 is 5. The same is 2, 5, 25. Now here, difference between 7 and 3. Difference between 7 and 3 is 4. So that is available here. Difference between 4 and 3. Difference between 4 and 3 is 1. It is available here. So difference between the first two digits and difference between the next two digits taken as a resultant of that number. Now, 6 and 5. Difference between these two digits, 6 and 5 is 1. Difference between 8 and 2. Difference between 8 and 2 is 6. So, 6. So, the required number is 16. Choice 2. So, the required answer is choice 2. It is typical logic, I can understand. But one of the question we discussed in the way, so when you come across a new question, please try to think in this way also. Now, 7, 344. By writing, when I'm writing, I got the logic directly. 11 is to dash. 7, 7, 344 is nearest to cube. 7 cube 343 plus 1. Very simple one. 7 cube plus 1. N cube plus 1. Now apply the same logic. 11 cube plus 1. 11 cube is 1331 plus 1 is 1332. Is it available in the choices? Yes. 1332. Very easy one. When it is easy, when you are thorough with the squares and cubes, nearest to squares and nearest to cubes. If you are not aware of those numbers, this will become difficult. Next, 3 is to 30 proportion, 4 is to dash. I'll give you 30 seconds time. You may try it. 3 tens are 30, 4 tens are 40. Not available. 3 plus 27, 30. 4 plus 27, not available. 31. So think in a different way. 3 is to 5 square plus 5. 4 is to 6 square plus 6. 42. Not available. The given logic is 3 is to 3 cube plus 3. N cube plus n. N cube plus n. Similarly here n is 4. N is equal to 4. So 4 cube plus 4. 64 plus 4. 68 is the answer. N cube plus n logic, where n is the first number. Analogy. Okay. We are discussing here all different kind of logics. So please practice. Now, last question for this session. 36 is to 84. 36 is to 84. In this pair, you have to identify the logic. So by looking at this, here to here it is increasing. Okay, 36, 84. How much it is increased by? 36, 48. Yes, 48 plus 48. 27 plus 48, definitely not the 63. 21 plus 48, definitely not the 51. 57 to 135, there is a large gap. 45 to 95, it is just 50. But we require 48, so it is not the logic. So difference is not possible, then check in the product way. 36 to the 72. How much it is more than that by? 12. So into 2 plus 12. I may think into 2 plus 12, or also I can think at the beginning we discussed into 2, this 12 is one third of 36. You can also think in this way. 12 is one third of 36. So into 2 plus 12. Now apply the same logic. 27 to the 54. 54 plus 12 is 66. It is not available. But if I think in this way, 27 is to 50, 63. 27 to the 54, okay, plus the given number is 27 and one third of the 27 is 9. 27 to the 54 plus 9 is 63, perfectly matching. So my answer is choice 1. It is into 2, n into 2 plus n into 1 by 3. N into 2 plus n into 1 by 3. Okay, not only into 2 plus 12, this same 12, you can also think in a different way. That is, 12 is one third of 36. So by applying the same, one third of 27, which is 9. So into 2 plus 9 is 50, 63. Perfectly matching. I hope these logics are clear to you. So please keep practicing the more logics. If you get any doubt, please mail to us. Thank you. Have a great day.